Okay, so this is lesson 2.3, completing the square. It's a flipped class lesson, which means that you need to watch this lesson at home before coming to class, and then you'll practice your new skills at class, rather than me going over this in class with you. Gives you more time to practice, which hopefully will make you a better mathematician. So, first we have a nice little notes page. This page, if I were you, I would star, because this is going to give you directions on how to complete the square. Completing the square is a brand new thing to us. You've never seen it before. And what we needed was, we needed a way to solve things that we didn't know how to easily factor using the diamond method. So, if you do not have a quadratic that can be factored using the diamond method, you can solve it by completing the square. So anytime you get a quadratic in the past, you could always solve it by factoring. But now, you won't be able to always factor, so you needed a new thing to come up with. And that new thing is called completing the square. It might seem a little confusing, but it's really quite easy once you've learned these simple 5 steps. The first step, and it's very important, the first step is make sure you have an a value of 1. So this little value right here in front of the x squared, that thing always needs to be equal to 1 for our completing the square method to work. Once you've done that, your second step is to get all of the terms with variables onto one side of the equation and all of the constants on the other. So what we're doing is we're separating our numbers off. We're saying anything with a variable comes to this side, anything without a variable goes to the other side. Step 3 is what makes this so weird, but it's a little trick that someone a long time ago came up with, which helps us create a situation that helps us answer these questions. And that little trick is they divide the b term. So the b term is this thing up here, that b value. Whatever's in front of the x. They take that b term, they divide it by 2, and then they square it. And after they square it, they add that resulting number to both sides of the equation. That sounds strange. Step 3 sounds strange right now. I'll show you how it looks, and it'll look much easier than you think. Step 4. Because you followed that weird little step 3, what you did is you created something called a perfect square trinomial. So by following step 3, what you did is you actually created a trinomial that you could now factor. And I'll show you that again once we get a few examples in. Step 5 is square root both sides of the equation to solve for x. So these are your step-by-step instructions. They might seem strange right now, but what we're going to do is follow those instructions several times and answer some of these questions. So our first practice question, you see it says, solve by completing the square. If you tried to solve this thing using any other method, you couldn't right now. So you don't know any other methods to solve this thing. Our step 1 is super important. You look at your x squared term, and you make sure that the number in front of it is a 1. If there's no number there, then it's a 1. So step 1, complete. Step 2 was to separate things off. So we wanted all of our x terms on one side, and all of our constants on the other. So we need to move this 3 to the other side. We do that by subtracting 3 from both sides. So we now have x squared minus 10x equals negative 3. So step 2 was separate all the x's to one side, all the constants to the other. We've done that. Step 3. Step 3 was the weird thing here. And what it said to do, it said to take the b value. Our b value is negative. What I do is I write it off on the side. It said take that b value, divide it by 2, and then square it. And whatever your result is, our result here, negative 10 divided by 2 is 5. 5 squared is 25. Whatever you get, they said add that to both sides. So once there and once there. So you now have x squared minus 10x plus 25 equals negative 3 plus 25. So what we did there is we took that weird formula, b squared divided by 2, and we added it to both sides. Now what that does is it creates something on the left-hand side that can now be factored. This thing, it can be factored. If you were to create a diamond for that, and you ask yourself, what things would multiply to be 25 and add to be negative 10, you get negative 5 and negative 5. We call this a perfect square trinomial because you'll notice that your two answers, negative 5 and negative 5, are the same. And those numbers are half of your b value. So this thing will always factor to become x minus your b value divided by 2. And in this case, it's 5. We have 2 of them, so it's squared. You could have written x minus 5 times x minus 5, but that would look silly. So what we do is we write it x minus 5 squared. And it's equal to negative 3 plus 25 is plus 22. No need to write the plus in there. Now that you've created a situation you can actually solve. We've solved these before. We need to square root both sides so that it cancels and cancels. When you square root both sides, it's very important that you use a plus and a minus symbol. Remember, we've discussed that every time you square root something in this class, you get a positive and a negative value. Your last step now is add 5 to both sides. And you get that x is equal to 5 plus or minus root 22. So there's actually 2 answers here. Answer 1 would be x plus root 22. Answer 2 would be x minus root 22. Now I suggest that you pause the video and try question B on your own and see if you can follow those steps. Hopefully you gave it a shot, you have an answer. I'm going to go through all the steps again and try to get an answer as well. So my first step was check my A value. Make sure my A value is 1. It is 1, there's nothing written there. My second step is to separate things off. We wanted all my x's on one side and all my constants on the other. So I move my 3 over. We then do something strange and we follow that little formula. That formula was take your b value, which is 4, divide it by 2, and then square it. Whatever your result is, you want to add to both sides. So 4 divided by 2 is 2, squared is 4. So we're going to add 4 to both sides. So it's x squared plus 4x. And in red, so it sticks out, plus 4 equals 3 plus 4. Now, the reason we did that third step to get this weird thing that we could add to both sides is because it creates a trinomial we can now factor on the left-hand side. So we can factor this thing, and it will always end up being x, and then it's going to be b divided by 2. So 4 divided by 2 is plus 2. It'll always factor to be that. And if you're not sure, you can always diamond method that thing. So if you wanted to look, things that multiply before and add to before are 2 and 2. And that resulting numbers on the side is always this number divided by 2. And because we have 2 of them, we square it. And it's still equal to 3 plus 4 is 7. Once you've done all that confusing work, it goes right back to the basics. And the basics are solve this. So we need to square root both sides. The square and the square root cancel. So we now have x plus 2 equals the square root of 7. But what do you always put in front of a square root now? You put a plus and a minus answer. Your last step is subtract 2 from both sides. So you get x equals negative 2 plus or minus root 7. That's your answer. Hopefully you got that right and tried it on your own before you watched that part of the video. Alright, we're going to do it a couple more times, but a couple harder ones. So this first one, you look at it and you already realize it's kind of hard because you've got all these fractions. And what I like to do is I like to have numbers that aren't fractions. So anytime I see something difficult like this, if I see fractions or I see decimals, I want to find a way to make it easier. How can I make this question easier? Well, I could get rid of the fractions by multiplying everything by 2. See how this fraction is divided by 2 and this fraction is divided by 2? Well, if we multiply by 2, those things will cancel out. There and there. So now we have an equation of x squared plus 6x minus 9 equals, and notice that I did multiply the 2 on the other side, but 0 times 2 is still 0. I do that right off the hop, my first step, because I hate fractions and I want to find a way around working with fractions. Now we go back to our little rules which say factor this thing using completing the square. Your first step was look at the a value, make sure it's 1. The a value is 1. The second step is to get all the letters on one side and all the constants on the other. So I add 9 to both sides. I now have x squared plus 6x equals 9. So step 2 is complete. All the x's on one side, all the numbers on the other. Constants, not numbers, all the constants on the other side. Step 3 was take your b value. My b value is 6. Divide it by 2. And then square it and add that to both sides. So we're going to add 9 to both sides. So I took that little weird formula, b divided by 2 squared, and added it to both sides. Now I've created something on the left that can be factored. If I factor that, it will always be x, and then whatever your b value is, divided by 2. So plus 3, and it's always going to be squared. If you wanted, you could have diamond method that again. So things that multiply by 9 and add to be 6, 3 and 3. Notice that there's 2 of them, that's why it's squared. Now we just solve for x, so we square root both sides. It cancels. We have x plus 3 equals plus or minus root 18. We then subtract 3 from both sides, so x equals negative 3 plus or minus root 18. That would not be the answer that appears on a test. We just completed Unit 1. Unit 1 was simplifying radicals. If you look at our radical here, square root of 18, it is not simplified. Because 18 can be divided by 9, and 9 is a perfect square number. So what we need to do is make this x equals negative 3 plus or minus 3 root 2. That's your final answer. So we changed root 18 to become root 9 times root 2, and the square root of 9 is 3, which is why that 3 came out front. Remember, that's unit 1. So you need those unit 1 skills to transfer forward all year. All right, we try one more. Okay, we look at this one. It says solve by completing the square. If we tried to solve by factoring, we would fail. We wouldn't be able to find numbers that work. So we go to our rules, and our rules say step 1, check your A value. Make sure your A value is positive 1. It's not positive 1. Now, unfortunately, this makes things messy. Because the only way to make it equal to 1 is to divide everything by whatever your A value is. So I'm going to divide every single term by negative 5. And you notice that that makes things messy because 2 divided by negative 5 is not going to work out nicely. These will cancel to give me x squared. The next one will become plus 2x, which that one's not bad, but it's this constant that's not so nice. Unfortunately, when your A value isn't 1, that's just part of what you have to deal with. Notice we leave it as a fraction. We don't change that to a decimal. You want it as a fraction, and I'll show you why in a bit. So, step 1 was make the A value 1. Step 2 is to move all of our constants to one side. So we need to add that 2 over 5 to both sides. So plus 2 over 5, they cancel, and plus 2 over 5. Our third step is take your B value, divide it by 2. So our B value is 2, divided by 2, square it, and whatever you get, put it on both sides. So 2 divided by 2 is 1, 1 squared is 1, so now we have x squared plus 2x plus 1 equals 2 over 5 plus 1. 2 over 5 plus 1. I'm going to write this right at the top of the screen. So 2 over 5 plus 1. I'm going to put that in my calculator because I want to combine those. And when I go 2 divided by 5 plus 1 in my calculator, it's going to give me a weird decimal. I'm going to hit math, and then fraction, and then enter. And I'm going to change that into a fraction of 7 over 5. So we want to use a fraction instead. So we're going to change that thing into 7 over 5. We're going to rewrite everything out. But it's now 7 over 5. I'm changing the way my fraction's written. It's not on an angle anymore, but it means the same thing. Okay. Now that we've followed step 3, we have to do step 4, and that's factor it and then square root things. So on this left-hand side, you see we have a perfect square trinomial, which means we can factor to be x plus 1 squared equals 7 over 5. We then have to square root both sides. We've got x plus 1 equals the positive or negative root 7 over 5. We're going to subtract 1 from both sides. We now have x equals negative 1 plus or minus square root of 7 over 5. Now the reason why I left it in fraction form is because now we have to go back to our Unit 1, and we need to remember all of our radical rules. So we can rewrite fractions as square roots separated from each other. So instead of square root of 7 over 5, it's now the square root of 7 divided by the square root of 5. And we know that there's a rule in math, and that rule is you're not allowed to have square roots on the bottom. So we have to get rid of that square root of 5 on the bottom. To do that, we multiply by square root of 5 on the top and on the bottom. This is called rationalizing the denominator, if you want to go back and look at your notes. On the top, what we do is we multiply the radicands together. So 7 times 5 is root 35. And on the bottom, because the radicands are the same, the radicands cancel out the square root sign. Okay, this answer right now that we have is pretty darn good. But it's still not quite good enough. Because we like to write our answers all as one big fraction. And right now, we have -1 and then plus or minus a fraction. So what we need to do is somehow combine these things. To combine these, they need to have a common denominator. So we need to make this -1 over here. We need to give it a common denominator of 5, like our friend to the right of it has. So -1 can actually be changed to be -5 over 5. See how they have the same denominator now? So we rewrite this as x equals -5 over 5 plus or minus root 5 over 5. When you have a common denominator like that, you can just write it as -5 plus or minus root 5. Sorry, that's root 35. I typoed that. Square root 35. Square root 35. And it can just become one big fraction like that. And that's the most typical way you're going to see an answer, as one big fraction just like that. These final steps here are what separate a 90% student from an 80% student in our class. So if you can remember all those steps, that's what's going to push you the extra mile on some of those really hard questions on a unit test. Likewise, word problems such as this will do the same thing. So a person stands on a cliff that is 55 meters high and tosses a stone. It hits the water a few seconds later. The approximate height of the stone, h meters, so height, h meters, above the water after t seconds, so t means seconds, is modeled by that formula. When will the stone hit the water? When means what time will it hit the water? Remember, my trick to this is look for the info they've given you. Somewhere in there, they gave you info. They told you that you were 55 meters high. Because you're 55 meters high, that means they've given you a height. So in your formula, change height to be 55. Oh, I'm sorry. Erase that. That's not where the stone lands. That's where he started. So this is actually an even trickier question than it looks. Because they're not saying that h is the height of where you are when you toss the stone. They're saying h is the height of the stone. And what's the height of the stone when it hits the water? So that's the key here. Height of the stone when it hits the water. So this is one of those distractor questions. That 55 meters high is a distraction. Because it's talking about you, not the stone when it hits the water. So what is the height of a stone when it hits the water? If you think about that for a minute, the height of the stone when it hits the ground would be on the ground. It would be at 0 meters. So that means h in your formula needs to become 0. So you have 0 equals. That h is 0. And I'm going to reorder that quadratic to be something we're used to seeing, and that's with the t squared going first. Notice that they've written it different just to kind of mess with us. Now we're going to solve this thing by completing the square. I'm going to go quickly through this because you should be good at completing the square by now. So I need a value of 1. So I divide everything by whatever my a value is. My a value here was negative 5. Now I have t squared minus 6t minus 11. Step 2 was move anything to the other side. So now we have 11 equals t squared minus 6t. We now have to add a value to both sides. That value follows a formula. The formula is b divided by 2 squared. So we're going to add negative 6 divided by 2 is 3. Squared is 9. So we're going to add 9 to both sides. We're then going to factor the side because that value created a beautiful situation where I can factor. We're then going to square root both sides. So we're going to get the square root of 20 equals t minus 3. And lastly, we need to remember that there's a plus minus in front of the square root. We add 3 to both sides. So t equals 3 plus or minus root 20. If you put that in your calculator, you are going to get 2 answers. One of them is going to be a positive answer, and one of them is going to be a negative answer. Because that's what that plus minus does. We need to make sure that we only use the positive value, because the negative value in this case wouldn't make sense because you can't have negative time. So if you calculated both your answers, you would get t equals 7.5, and you would get t equals negative 1.5. Depending on whether you use the plus or the minus symbol. The plus symbol gives you this answer. The minus symbol gives you this answer. That one does not make sense because you can't have negative time. So your final answer is right there. Alright, that does it for the video. See you in class where we will practice some more of this.